Welcome everyone. Thanks Diana for the lovely music, and thanks for your introductions in the chat. My name's Sue Sentence and I'm from the Raspberry Pi Foundation, and I'm delighted to be chairing this session today with Genevieve Smith-Nunes from the University of Cambridge, who I'll introduce in a moment. And welcome all of you to the next of our Raspberry Pi Foundation Computing Education Research Seminars. We've been running a series on cross-disciplinary computing, so that gives us a license to put in all sorts of lovely, exciting things like dance for a little while. This is, I think, the fifth out of 7 of these seminars. It seems like ages since we've had one, because we had a little break over the summer, so it's really nice to see you all back again. And in this series, we're looking at all sorts of aspects of computing and the interactions of computing with various aspects of learning and life. So without further ado, I'm delighted to introduce Genevieve. And I'm going to read the whole bio because it's so interesting. So Genevieve is a third-year PhD student at the University of Cambridge, and she also is a lecturer at the University of Roehampton. In 2013, she set up Ready Salted Code, which is an organisation which provides innovative digital computing STEAM-focused education. This includes providing data-driven dance performances, large-scale technology-enhanced classical ballet performances, and is designed to explore the ethical and social justice implications of future technologies. It's a complete honour and delight to be able to introduce Genevieve to you. The title of her seminar is Me++, Data Ethics for the Computing Classroom Through Biometrics, Ballet and AR. Sorry. And, and now I'll mute and let you share your slides. Thank you.
Okay. Thank you for that wonderful introduction, and hopefully you'll enjoy the little journey I'm about to take you on. So if you do want to screenshot any of the slides and share them on Twitter, I would like you to add some alt text, if that's okay, and be mindful if you do capture anybody else's image on the little sidebar. If you've got any photographs of other people in there, just for the ethical implications of sharing personal data. Got to start properly. Feel free to post in the chat any questions, and also feel free to answer other people's questions if you actually have an idea and things like that. So it's a collaborative sharing process. It's not just about listening to me talk about weird dance. So, so the reason why I'm interested in data ethics is a kind of ongoing story. So I will briefly talk a little bit about me, then about the way that I created Ready Salted Code and data-driven dance specifically, and why I use classical ballet, before moving on to the sort of technical aspects of the sort of AR-driven biometric data ethics element of this particular research project. There's a few little links that I will put in, so you'll be able to get a play around with some of the technology that we're using. So I, as Sue introduced, I've been a lecturer, but prior to that, I was actually a classroom teacher. And I taught, initially taught maths and computing. Well, it wasn't called computing, it was called IT then, at a secondary school in Brighton, before moving on to a FE college to teach A-level computer science and software development games design. And then from that, I kind of realized that there wasn't very many girls in my classes. So I had 80 A-level students and only 2 girls out of the 4 classes. And when I was teaching GCSE, I had 1. And my background is in dance. I went to dancing school from when I was very little. So for me, there was a quite close affinity to how ballet is structured and works, along with programming, because when I would want to play a computer game, it was slightly different, and it did take a few kind of lines of code even just to load up the game. So one of the things that I do is I collaborate with other people in terms of when I do the data-driven dance. So it's not just my project, it's always with a collaboration with other people. And that's really important. So I work with a technologist called Alex Shaw, who's amazing, and a choreographer, both of classical and modern dance, Camilla, and they're based in different places across the UK. So just to give you an idea of kind of what the challenges I faced in a young person. So this is my favorite game from the Dragon 32 called Ice Castles. It took 110 lines of code before you could load it. And it still looked like that. I think I'm showing my age, but I still really love the game. So I was brought up with this idea of having to actually code a lot of kind of, even just to load Lotus Notes to do my business studies, GCSE. It was all command line basic stuff. So I was very familiar with how that worked. And at the same time, I was at dancing school doing classical ballet. And classical ballet is incredibly rigid. It's got very strict routines, functions, and forms. It's got a very strict language that you have to use if you're using traditional classical ballet, as opposed to modern, contemporary, or other forms of dance. So I was dancing like up to 5 times a week, as well as sort of playing on the BBC Americas at school and the Dragon 32 at home. So there's quite an alignment between how the two things function for me. Unfortunately, at 16, I had a spinal fusion, and then 18 months later, I had to have another one. So the kind of dance career ended. But my kind of love of performing and my understanding how the sort of, the sort of computational choreography of ballet was aligned with computing, I just never really got to do it until I was much later. So this is where I ended up in 2011 thinking, how can I do more ideas that would be engaging to people who are more interested in arts. It took quite a while, and then in 2012, 2013, I applied for a Google Rise Award to enable me to create this classical ballet and the educational instructions that went with it. And we launched it the same September as the new computing curriculum. And it was about how can we use the new computer curriculum as the kind of story, and the ballet was the narration of those theories and concepts. So we produced 3 ballets so far. I always say we because it's a collaborative project. Sometimes some of the stuff is me, but it is the collective we. And they're all data driven in terms of how we have to approach the actual project as well. So we do lots of skeleton tracking. Initially, we just used the Connect, because obviously this is 2012, 2013. It needed to be able to run in a classroom. So it couldn't have all of the kind of, proper motion capture, because you're never going to get that in a classroom, but you can get, a Connect bar off eBay or, so we built some software that allows you to capture the skeleton data, and then it converts it into JSON data, which you can then use for visualizations, such as the one behind the dancer on the blue. And that was like live weather data of the storms of 2013 at the time, 2014, sorry, in the summer. And the dancer's choreography in terms of its pattern on the floor, like if you were looking down, took the weather patterns in order to create the interactions. You can't quite see it on that photograph, but they do have wearables both on the point shoes and on the dresses and in their heads. And these were passive. They didn't take any data from the dancers, and they didn't input. We got the dancers to do some pattern coding, very simple, because none of them were actually computer science students. And the one with the 2 dancers has a lot of different visualizations, and that particular ballet Pain Bite was about chronic pain and biomedical engineering. So conceptually, we looked at things like the pain gate theory, how the implanted technology works, because at the time I'd had my first or second spinal implant. And It's called a high frequency spinal cord stimulator. I think about like a bit like a pacemaker, except the electrodes are against the spinal cord, and it's about trying to disrupt the pain signals in the body. So we were trying to show that actually, implanted technology isn't, Terminator Rise of the Machines, but actually it can be beneficial to people in different ways. So with that one, the dancers had pulse sensors on and pressure sensitive plastic called Velostat. It looks a bit like a garbage bin liner or a bin liner, and it allows you to, the different pressures create a signal, and you can allocate a variable number to that and use that as part of your code. So what we did with the Connect, this is the original kind of Connect before we move on to what we've had to do the AR stuff. So this was the Connect, and then it was using JavaScript and D3 library in order to a binary tree structure that and then eventually turned into an actual virtual dancer. So this is the end result of that, so that we can think about like how the structure, the anatomical structure of it. And the interesting thing from the dancers and the choreographer and the technologist, we can tell who that dancer is because your gait is as personal as your fingerprints. It's like as identifiable. So it's quite an interesting, it was interesting to see the different dancers, and they would be able to recognize themselves, and that's something that we picked up later on. And then we do use different technology boards like the Pi Zero and things like that, but on the point shoes it's quite hard. So we tended to use the Gemma or the Flora, depending on what type of data that we were trying to do. Again, conductive thread and point shoes are very tricky. They actually broke pretty much every performance, and we'd have to restitch it. So I wouldn't advise it, but I would use it on other stuff. It's actually really good for that. But anything that's got a lot of stress and pressure is actually quite a difficult thing to do. So the other thing that we ended up doing, which is an alternative, but you may or may not be able to do this in your classrooms or your after school clubs, is soldering. So we soldered them together with very, very thin wire, and then just actually used like plaster, like sticky plaster for covering up a cut to go over the point shoe. So the lights just shine through, and it actually had some movement in there as well. So fast forward a little bit and we come to where we are now. So when I started working on my PhD was October 2019, and there was no COVID. So I had all of these plans to use some of the software that we'd already built to capture the biometric data. We have a little bit more sophisticated software than we did use on the very first ballet. And then fast forward to when I'm allowed to go and collect all my data, and everything had to be virtual. So the whole redesign of the project was quite interesting, and initially a little bit challenging, because how can I create 3D avatars from in a virtual environment? So it took a little bit of research with myself and the technologist to see how we could actually capture data, and that would capture data that would work for actually creating these 3D characters. So what we use is either Zoom or your like mobile phone. We tended to use it at 60 frames a second if it was on the phone, because dance is especially ballet, is very fast. So the rotational, you can imagine how many frames you might drop if you're on a 30 frames per second versus 60 frames per second. So to avoid as many errors as we can, we try to do it as high resolution as possible. And then the machine learning kind of models that we use are OpenPose, and then also MoCapNet2. And I'll talk a little bit more about MoCapNet2 because most of the what these video to skeleton tracking machine learning models do is they look at the video and then try and work out where each of the points of data of your joints are in a 3D space. But they tend not to have feet. They tend to stop at your ankles. And if you're doing ballet, you need to be able to rise up on point and down again. So it took longer to find a machine learning model that actually worked for us. And then again, the vocabnet was designed by academics and not by sort of games developers that would then push something out into like Blender or Unity. So there's some of the challenges that we face there. So this is what it looks like. This is me in my ballet class at home. And this is the open pose one. And you can see that there's no feet in this particular one. And then later on, we used the actual mocap net in order to gain the feet. The other challenging thing is most of the training data for these particular models. So you can all go and play with these. So like Open Pose Net is online. There's a few other different variants and you can actually just go and play. And I'm going to give you some stuff to play with it a little bit later on. They expect normal human motions. So they don't expect a ballet dancer's leg to be up here. So we've having considerable challenges of where joints and body data is actually. So we've had a lot of legs coming out of heads. We've had a lot of rotational body, so the body gets inverted, which is actually quite funny, but slightly disturbing. It doesn't actually do what we want it to do. But you know, you will get there in the end. So this is what the actual model in the blue looks like from MoCapNet 2. And then what we did is that we built a little frame VR, so an online VR environment to showcase some of this. And I will just get you, so I'll just post the link so that you can see it. So the reason why I'm not sharing it is because it's frame VR, it's actually going to run really slowly on the Zoom. So in order to miss that out, we're going to I'm just going to go and post the link in for you in the chat. Sorry. So it may be a little bit slow if you're running it on the same device that you've got, but don't worry too much. So this is the little picture at the bottom, shows you frame VR and actually what we ended up doing as a test model of me. So this is from that same ballet data. We actually then pushed it through Make Human, which is a way to create very anatomically correct. So if you are going to use it in schools, do be mindful of that. And Blender to create the 3D model. And then we actually just exported it as actually a 3D model. So this is where the challenge was, because obviously a lot of the joints in the body weren't quite working as we wanted them to, which is a bit of a shame, but you know, it is what it is. So and this is what the sort of static VR looks like. And we had to create new particular software to get the joints to attach to the correct parts of the body and to get them to rotate in the correct way. Still not quite working, and I'll show you a video at the end. It's actually quite funny, but that's kind of like some of the challenges that we face from a technical aspect. It's really good fun, and you can use lots of different ways to actually just engage with the technology, and especially when you can push it out to Blender. There's a lot of free software, so the Open Pose is free, you know, Blender is free, so you can actually work with these yourself. Did you take a little bit of time to work with? And again, depending if you're in very younger years, I wouldn't advise doing that. This is much more kind of A-level standards, maybe some GCSE stuff does. We've got, so in terms of the data ethics, you can imagine the amount of data that we're recording. So we're recording all of these videos, all of these Zooms, in order to not only rehearse the ballets, but also to capture that body data. And then we're looking at very different parts of it. And so we need to be very mindful from an ethical point of view about the individual participants' data and how we use it. And this is where it's really important for me to talk about data ethics. So, and again, it's a very specific one. You might, a lot of sort of data ethics now might fall under AI and ethics, and certainly in terms of frameworks. And what we need to think about when we're interacting with our students or our learners is how much data are we collecting and using with them and for them, and then what happens to it afterwards. So this is where we need to think about what is the data I'm using, and what are the ethical implications of those. And especially as teachers, we're constantly, marking them, assessing them, logging all of this data on each of the individuals. So we need to be mindful of that. And this is where we have to look at specifically a particular blends of different frameworks. So I look at kind of the philosophy of information from Floridi, which is one of the papers that you can see here, alongside neuroethics, because we use brainwave data as well. So in terms of which framework you use, there are so many, and this is where it can be a little bit challenging because you can get lost in the data. So I've gone for a couple of different frameworks that are quite useful. So the gov.uk data ethics framework is really clear and really easy to use, and therefore is transferable to different types of learners. And they have just 3 guiding principles, where a lot of other frameworks may have 5 or 6. And I've just put on the other side where it may come into the specifics of the computing area. But one of the really good things about the sort of data ethics side of it, it can come into the business studies classroom. It can come into the maths if they're doing any sort of personal data collection, certainly into RE and PHSE from different areas. So there's really good ways that you can actually link the discussion side of it with different parts of the actual curriculum. So, and then we need to also tie into understanding data in terms of what are our biometric data that we share. So us as individuals are constantly sharing our data. And we know that already from all the algorithms, but also in terms of our facial recognition, our fingerprint ID. But then our students are often doing that in terms of how they log on, how they buy lunch, how they may actually, book out a library book, may also be fingerprint ID. And if you think about, well, what happens to that fingerprint? Who's collecting that data on behalf of the school? Where is it stored? And when they leave, where does it go? And what was interesting for me was just yesterday, I got an acceptable use policy for my youngest son's school. And in there was an additional paragraph that wasn't in there last year, which was about data deletion. And that was lovely for me to actually see that actually somebody had really thought about the students' data and actually what are the implications of actually keeping that. We tend not to think about that too much. There's a couple of different frameworks as well. So the new IEEE standard, which is at the top, is actually also part of the children's code that came into play. And I was lucky enough to be one of the people that wrote this framework. And then there is also a couple of other frameworks across the world, which I'll share because there's quite a lot of them when you get the email afterwards when they share the links. I don't want to overwhelm you. But it's quite interesting to think about where this is going. So Australia are currently just looking at their whole framework for children protection, data privacy, and also in terms of the ethical implications of what they call is information. So they include other types of different information when they're talking about that. So biometric data and ethics is generally just subsumed into these AI frameworks. It's also covered, there's a biometric addendum to the GDPR that came in December 2020. And it's a really interesting way to get into the discussion of data ethics by talking about our biometrics. And that's things like, for this particular project, is your skeleton data and your brainwave data. So this is where we have to talk about the neuroethics side of it, which is the brainwaves. So neuroethics is concerned about the sort of ethical issues when anything that involves the brain. The particular technology I use is a EEG headset by Emotive, and it is a 5-channel wireless headset, and it allows you to passively record the brainwaves. And I will share a spreadsheet of my brainwaves as well, so you can have a play. But this is what my actual brainwave looks like when you visualize it. And it's part of a way to visualize live with the headset on. This was me when I was editing one of my chapters, so it's quite red. I was feeling a bit stressed, I think. But the more you, one of the interesting things, the different ways that you can actually record the brainwave data. Now this looks beautiful, doesn't it? I mean, it's really pretty. It doesn't necessarily feel like someone's data, but it is. It was a live recording of my brain. At the same time, so was this. So this is the actual raw data in a graph form. And when you export that data, you can export it into a proprietary kind of format, or you can export it into a CSV. So one of the things that we've been talking about with the participants that have been sharing their brainwave for this project is, how do they feel about sharing their own biometric data? And the really interesting thing that came out of it was they thought that the brainwave, the brain viz, the previous one, was beautiful and it was lovely, but they were much more concerned when they started seeing the graph data and they started seeing the spreadsheet data. And that was a really interesting observation, because it's the same data, it's just presented in a very different way. They came up with different ideas of why that might be, and you might have ideas of why that might be. And one of them was that the graph data particularly has a medical connotation. You know, you see it all on the movies, and so it has like a sense of fear or a sense of danger attached to it. This is what they were saying. And they felt very cautious about sharing it, but less cautious about sharing the brain viz, the pretty one. So the other questions that we need to think about is how secure. Obviously these are secure because they're not uploaded anywhere. They're on the laptop. So obviously once I export the data, that is stored somewhere else. But the majority, the data that we're sharing from the project is mine and the technologists. And some of the questions that we're asking the trainee teachers is, how could your brainwave data be used in the future? How could your biometrics be used in ways that aren't necessarily for the benefit of the individual? If we think about how, you know, the nudging that goes on in terms of how algorithms work, and you know, and how your feed on your social media, especially for young people, because that's, you know, they're engaging a lot in social media. So if we're then starting to interact with biometrics, so things like microfacial expressions via video cameras, or in this case, you know, apply to university and share your brainwave map with us. You know, hopefully not, because that would be hideous. But we try to, you know, prompt them with these kind of dystopian ones. And then they were talking about how if you on the other side is, if you're dancing together, can you try and sync the patterns because you're actually doing the same choreography? So that was really interesting. So this is where the Me++ comes into it. So it's the data self and the human self, as in the flesh and body, and both are important and of equal value in terms of, you know, there's not one hierarchy over the other, especially when we live in a sort of digitally mediated world. And I borrowed the title from this amazing book. Hopefully you can see that. So, and I'll share that later with you. So it's called The Cyborg Self and the Network City. And it's William J. Mitchell, who was an architect lecturer at MIT. and he was talking about how the sort of the wireless biped within the city and how technology is sort of networked and how we sit within that. And that's really interesting. Yes, nice point, Juliette. The graph seems more permanent. That was the other thing. Yeah, the sort of the concrete nature. They said that actually the spreadsheet felt more permanent, but that might be because they're so used to using spreadsheets from school. They were like, so they were familiar with that. So that's quite an interesting one. Whereas the brain biz is quite a sort of abstract art interaction, not necessarily the same thing. So this is it running. And when you start dancing, it also picks up motion as well. So that was some of the very big, large peaks and troughs are actually motion. So I was just jigging about to see what would happen while I was editing my chapter. But yeah, so one of the ways that I take the sort of less complex technology that we use to create the skeleton tracking that we use is something called, I use p5.js, and they have a machine learning library or model called ML5. And in terms of how, I'm just going to give you a link to it. So there's a few different ones that you can use, and you'll be able to test these on your phone. So there's a couple of links coming into the chat just so you can see it. The one that's on the screen is called Mirror Threshold, and they're the two filters that I use. And the reason why I did this particular one was to show that split between the human and the data self, and the actual skeleton is offset. So there's a different one which is using a facial map, and I will just yeah, you have a nice blue face going on. Yeah, that's pretty cool, that one. I quite like that one though. That's quite fun, and the code in it is quite clear. So the really good thing about using p5.js is that it allows you to not have to install any software, which is such a bonus. And the other thing is that it allows you to also talk about web technologies, because if you where you can just see the sketch.js, it's just showing the JavaScript code. Next to it on the little arrow, if you expand it, it'll give you the HTML and the CSS. So you can actually do some web technology in there as well. And there is loads and loads of tutorials that are for this particular platform. And there's a special web page for the ML5 library. So one of the other good things about this particular one is they are very clear in their documentation that they are not actually recording any of your data. And that is really, really important to me when I'm dealing with classroom students or people in workshops that aren't part of my research project. I do not want to be putting them in a situation where they feel like their data is not being protected, and their data is then recorded and used and stored somewhere else. It does need access to your camera, because how else is it going to pick up your skeleton? But other than that, it's actually quite interesting in terms of how you can play around and do these amazing things with just web stack technology. This, you can create like if you have a look at the gallery from the p5.js gallery, the amazing thing that some of the people have done are just mind-blowing. So this uses the machine learning model of PoseNet, the one without the feet, which is why we couldn't use it ourselves to create the AR particularly. So one of the things that we have to think about, so this is it's blurred, so you can't see any of my dancers, but this is the particular data that we're using that allows you to isolate the particular dancer out of video, because we had two dancers together. It allows you to think about how you might talk about the assumptions of actually all of these things are assuming that you're able-bodied for a start. It assumes that you have, you know, 2 arms to your legs. It will work if you have 1 missing limb, not as necessarily like permanently, but in an occlusion sense as well. And so the other is that they're tested on very standard sort of dance, you know, like maybe just like people dancing around like this. They're not tested. There is no training data for ballet for these particular machine learning models. So we spoke to Dr. Shamanenska at Sussex about how can we improve it. And her first response was, you need to write your own neural net. And I'm like, that's not really my skill set. So that might be for a project later on. But it was quite interesting though, because we do have something like 150 hours worth of dance data. So it would be an interesting project for other people to do. So a lot of these things, which obviously you can imagine, have a lot of military applications. So for example, Spot the Dog, you know, the Boston Dynamic robot, which is now owned by Hyundai. So they actually got a choreographer in to help with the movements, and their actual software for movement is called choreography, because they wanted it to have much more human like movements, and the way that we move as dancers is slightly different to how we would actually do that in terms of kind of normal weight, the normal movements that we do. And then the other challenge that we've had is because the machine learning algorithm is by academics, it's not quite open source. So you can see, you can't actually get it. You can have the code, but you can't see how they built the training data and stuff. So we can't actually fix some of the things as we would do normally. So the other thing that we are doing with the brainwave data, the CSV files, is data sonification. And obviously, I haven't shared any of this because we're still in the process of making it. And it's a really good way to think about how you can interact with sounds. You know, you don't necessarily have to use brainwave data. So you can think about like how NASA do, if you look on SoundCloud, they do data sonification of all the stars and pulsars, and it's the same process. And this is a really nice way. So you can do this in Python and you can do this in Sonic Pi. So these are really good ways to link into the same code base that you might use in your classroom, but actually just a really good way to actually, how would you read and interpret data instead of maybe making like, you know, some of the projects that we might have done like bingo card generation or other sort of data-driven code that comes into doing that. So, and then the other things that we can do, so obviously the little code that I got you to have a play with, and I'll share some of the links later on about how you can do that. So skeleton tracking, so the software that we built and that just uses a Connect is available, or you can just use a skeleton tracking from pfad.js and the ML5 library. You can also think about how the ethical implications of chatbots and how they're collecting data and how you might do that, the filters that we use and how we edit them. And then Coded Bias is a really good documentary. It's a brilliant one. It's quite long, so you might have to break up or just do snippets if you were doing it in a classroom or an after school setting. So this is the AR not quite working. As you can see, it's a bit weird. And the bodies aren't quite right, which is why I've left it to the end. So this is the challenge that we're facing, because the machine, it's still not quite getting the dancers. It's rotating the body and the legs in different ways. So this is our current challenge. But it's quite an interesting one, but it also poses some interesting ethical questions about like what's happening to the data. It gives you a really good prompt. It's terrible for actual ballet production, but it's not. but it's great for research, but it's not great for production. So. And I just want to end on that before we go into the discussion prompts. So in terms of what I do is about bringing, using ballet as a programming language. and looking at, yes, nice one, Stardust, yeah, that is great. And how we can incorporate cutting edge technologies to talk about ethical implications of our own personal data. But yeah, so I have 2 little prompts for you, but feel free to discuss other stuff. So, but thank you.
That's fantastic. That was so interesting. Thank you so much. So we'll give you a wave or a thumbs up in the
Jazz hands.
chat or whatever in the in our little corners of our little boxes that we look at you in Zoom. And thank you so much. That was fascinating. Thank you everybody for coming along to this session. And Diana's put a slide there that's got the survey that we share with you at the end of every seminar. The link there. We really like to have your feedback because it helps us plan the next session. But we've got, we are already planning the seminars 2023, so you can actively make a contribution to what we do by giving us his feedback. Next month we will be we're very delighted to be having Conrad Wolfram, who's talking about building tomorrow's core computational curriculum. Conrad's it comes from the perspective of mathematics. He has some has already written books and is a very interesting speaker on the intersection of maths and computer science. And then after that we've got our own Tracy Gardner, who could wave, who's and Becky, talking about the work that we're doing at the Raspberry Pi Foundation in computing education non-formal. In December we're having a little break, and so thank you very much for coming along, and we look forward to seeing you in October. Diana will send an email with Genevieve's slides, and also we'll have them up on the website very soon. And we look forward to seeing you soon. Thank you so much for being part of our community, and sharing with us and giving us all your input. We appreciate it. And you can now turn your mute buttons on, off, whichever way it is, so you can clap and say thank you to Genevieve and goodbye in person, and we'll all disappear off.
Thank you.
Bye.
Thank you so much.
Thank you.
Thanks
Goodbye.
very much.